guys, it's Dallin with BYU's FSAE racing team. I'm here to explain and go through some of the basics of STAR-CCM, which is a CFD software that can help us analyze our design and iterate and make a better aerodynamics package for our car. In this very first video, we are just going to be going over how to pull an airfoil profile from the internet so that we can then go and put that into STAR and do a 2D simulation. So a great place to find airfoil profiles is airfoiltools.com. It has almost everything you could ever want. So if I search for the CH10 airfoil, boom, there we go. It gives us our airfoil profile. You can see that this is a very high camber and relatively high thickness airfoil, and it's designed that way to get really big lift while operating in low Reynolds fuel flow. And so if we bring these back to the normal kind of default numbers, you can see that on these plots, the Reynolds number describes how fast you're going in comparison to the thickness or viscosity of the fluid, and the increment describes how turbulent or laminar the air tends to be. And so on these plots here underneath, we can see how coefficient of lift or downforce changes with angle of attack, how the drag changes with angle of attack, the efficiency changes with angle of attack, and so forth. Now, because we're going to be operating in air, which is very not viscous. We're going to be operating at low speeds, and that's going to tend to be more turbulent. This is more of the range we're going to expect our flow to be in. And so you can get a kind of good gist of what the airfoil is like. And if you were to run a single element, you can do this 2D simulation and compare your values to these values here from Xoil, and then be able to understand, is my STAR working well? That's not going to be the purpose of this lab, but we can do another one later on. What we really want is this profile, stat file. So this stat file is basically a really fancy text file, which will give you all the instructions, a bunch of different dots that your profile will follow, to then be able to generate that wing. So we could at this point copy this, convert it into a CSV file, because that's what STAR-CCM wants, and you could be done. We're going to take it just a little bit farther to be able to iterate and give ourselves more points. Having more points will mean that STAR-CCM now has more spots to draw our splines for our lines, and as a result, we can get a much finer mesh. So I like to use a program called XFLR5 to do this. You can just click here on the downloads. It's based on Airfoil, which I already previously mentioned, and it works with Windows right off the bat. So let's launch that. And while that is booting up, let's save our .dat file. You just hit Control S to save. And it's going in my .dat folder, so that's perfect. And I'll call this I believe it's the CH10. The CH10 dot perfect. So now as I go to Xfoil, this is open. I hit Control N to start a new project. Control 1, remove the airfoil profile. And I can now open my profile and pick the CH10, open, and that should show up on our plotter. And we can, as a sanity check, just look at this old plot from Airfoil Tools. This plot, wow, it's the same airfoil. That's great. Now, if we want to give ourselves more data points, we simply right-click and refine globally, or you could press F3. Right now, we only have 79 data points. We're going to want around 200, should be pretty darn good. If you wanted to change how the points are spread out, right now, we have a 0.15 for our TE to LE density. So that means there's a lot more up here on the leading edge as compared to the trailing edge. That's totally okay, and so we will just apply this, click OK, and if you want to rename it, you can. I don't, it's the same airfoil, so I'm just going to click OK. Now, if you wanted to, you can pull NACA files from airfoiltools.com. However, if we go to foil, you can put a NACA foil in, and I also am really curious to see how 6318 will work, and so I will also put in, put in 200 points, please. Thank you. And we'll create that, and it's a NACA 6318, that's perfect. And so this is a very different profile, right? This is way further up. NACA has way less camber, you can see, but it is really thick, that airflow. And that max camber location is farther forward. It's farther behind. Oh yeah, it is farther forward. I'm correct. Okay, perfect. So if we want both of these, we can just export them. And I'll just name this one CH10 refined that. Save that. And then the 638, I want that as well. We'll just export that. Make a 638. I don't have one before that, so we can just save it as is. And if you wanted to save that project to keep these airfoils, you can. I don't. I've got what I wanted, so I'll just pull it out. So at this point, we can now go back to our profiles folder, go to the data folder, open up CH110. It'll launch Notepad. If you're a Windows user, you can grab our files from there. However, we need to get a CSV file. So I'm going to create a new spreadsheet, create the CSV. And although I'm not a huge Excel person, this is what most people use. I'm just going to right click and say open with Excel, not LibreOffice. And while that's launching, let's grab our data file. Oh, this is our old data. That's a good thing. Good thing it's still launching. I'm not wasting too much time, unless it didn't launch at all. It was launching. Okay, perfect. Well, let's go back here and let's go to our profile that, let's get CH10 fine this time. It's like 81 lines is not enough. We want 200. So let's grab all of those, or not. Let's grab all of those. Perfect. Enable editing on this, please. And we'll paste it in. Now, one thing you might be able to see quickly is that this B column is off center. And that's because there's actually not anything in the B column. It's all in the A column. And then, so even though each row got separated correctly, the columns did not. All we can do is we can click A to grab that whole column, go to data, text the columns, and we're going to use a delimiter to split this up. The delimiter, what's telling it, hey, these are different columns for these spaces. And we can just finish after selecting spaces. To quickly grab everything, just hit Control Shift right and then down, Control X to cut, Control V to paste. And just follow in these, which is a bunch of zeros. And it's a two-dimensional simulation that we want to get. And then you can save that if you want to go back to it. No, obviously, regulation. And then we can save as a CSV, and we can pick where we want that to go, which we don't want it in our Excel folder, we want it all of our CSVs. So after saving that, we are now all set, and I'll do the same thing without showing you guys the step for the Mocha airfoil, but that is essentially all the preparation work you need to do for our lab, where together we'll work through and we'll do a 2D simulation. I look forward to seeing you guys in the next video where we go over that. Thanks for tuning in.